Beautiful. No data, no data, no data. Data. Jackpot. Click. Click. Okay, ladies and gentlemen. Carrying on from yesterday, just a bit. Like I said, 0 hour this morning did real good. They really, you're tying so much of stuff that we know together. And so by tying all that in, it depends on how hard this lesson is or how easy it is, I guess, right? We're going to test claims about population proportions, right? Next week, no telling when, right? We're going to do 2-sample proportions. So we're going to do the difference. Gosh, I just tripped over that. Okay. So here we go. What we're going to be doing. Clicky, click, click. Why are you not clicky, click, click? Clicky, click, click. Clicky, 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 clicky. You're not clicky. Clicky, 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 clicky. Undo. Doom, doom, clicky. There you go. Y'all remember yesterday we talked about that basketball player making 80% free throws, right? And we thought that they were over exaggerating, right? And so we had ho, P is equal to 0.8, ha, P is less than 0.8 because we assumed they're lying. So we're going to try to prove that they're less than 0.8, right? And then they took, if ho is true, then 0.58, what values of P hat do we expect to see in 50 shots? So we're going to go back to chapter 7, sampling distributions, okay? We actually made 32 out of 50. Assuming ho is true, what are the chances of getting that 68 or less? And again, that's what the definition of the p-value was. That's what we talked about yesterday. In order to find that percent, we need to understand sampling distributions. So what do you know about sampling distributions? Well, you know the shape of the sampling distribution is approximately normal. But how do we know it's approximately normal? We got to hit the large counts condition, okay? You got to hit the large counts condition. So it will be, good gracious, where did it go? I turned you on. You're there, slideshow. There it is, good gracious. Will be approx normal. But the only way to prove that is by showing the large counts condition. And you guys should know the large counts conditions for proportions because N times P. That is one mistake that students make. They will try to do N times P hat because that's what we did last chapter. But if you know what P is, use it. If you know the parameter, use it. Last chapter, we didn't know the parameter, so we had to use P hat. Now we know the parameter because we said the parameter is right here. We said P equals 0.8. We said that. So if that's the case, then we know that's the parameter. So we'll do 50 times 0.8, which ends up being 40. And then we'll do 50 times 0.2, which is 10. Whew, that's close. That's close. But we know that these are greater than 10 or equal to. How about that? I can do that this time. So we know the sampling distribution is approximately normal. What do we know about the center? Oh, because of the large counts condition, the sampling distribution of P hat will be approximately normal. Okay? We know the center of the sampling distribution because you know mu of P hat equals P, which equals 0.8. You know that from chapter 7. So I know the center, I know the shape, and I know the spread because the variability is the square root of P times 1 minus P over N. Again, not hats. If you know what P is, use it. So we will go here and we will just say 0.8 times 0.2 divided by those 50 shots. We'll take the square root of that, and we'll get some number. And now we know the shape and the center and the spread of the sampling distribution of p hat, of the sampling distribution. Okay? Now, knowing that, assume ho is true, we know we have a shape. We have a center. We have a standard deviation. I don't know what that comes up to be. 0.0566. And we have a p hat of 0.64. I'm trying to find that probability. And you guys did this in chapter 2. We did it in chapter 7. I think we did it in chapter 4. I think we did this several times of finding the probability, knowing it's a distribution. And you can use one of three things: the table, which I don't think any of you guys use a table, calculator, or Desmos. Most of you use a calculator, some of you use Desmos. Either one of those two is fine, because you're just going to go normal CDF from negative 9999999 to negative 0.64. Sorry, not negative 0.64, 0.64. With that mean and that standard deviation. Good enough with all that? So it wasn't negative, it's 0.64. Okay? Good enough. That's what that distribution is. Well, if I don't want to find that proportion, I want to see how many standard deviations that is away from the mean. I want to see how many standard deviations that is from the mean. Rather than finding the probability of this, I want to know that standard deviation. And you guys know how to do that, because we know that the z-score is equal to p hat minus p over the standard deviation. And so I would do 0.64 minus the 0.80 over that square root of 0.8, 0.6, sorry, dang it, 0.2 over the 50, right? Doing all that stuff to find the z-score of this 0.64. So two things I can do. I can find the probability of this, or I can find this z-score. Click, just to kind of do this non-hieroglyphics. Here's the z-score. That's p hat, that's my sample. There's p sub 0. Notice that they'll do a p sub 0. The p sub 0 is the same thing as p. That's the null hypothesis. We know that this is p sub 0. Again, if you know the population, use it. 1 minus p0 n. And we're going to do all this little bit of math over here, and we're going to get negative 2.83. Right? Negative 2.83. So that means what? 0.64 is 2.83 standard deviations below the mean. And us knowing stuff about statistics, that's what? Too far away. That's too far away. But then we're going to turn that into a proportion, just like you did again in chapter 2. I think we did it in chapter 3, and I think we did it in chapter 7. Well, I know we did in chapter 7. So that z-score is called the standardized test statistic. That is called the test statistic. And it is very, very possible that AP asks you for what is the test statistic. Okay, what is? They may give you the test statistic. So you guys you gotta know that that test statistic is telling you how far away my sample is from the mean or from the claimed hope. Good enough with all that? Pencils, pencils, pencils. Good? Happy, happy? Can't see. Are you good? I'm lazy. I don't want to stand up. So that's a formula you need to know. However, you don't have to know it because it's on the formula sheet. What you do have to know is what? How to turn that into variables. You need to know how to turn that into variables. So the standardized test statistic is Z. You know statistic is P hat or X bar. In this chapter, that's going to be P hat. Parameter is the population. In this chapter, it's going to be P. Next chapter, or two more chapters, that's going to be mu. And then the standard deviation of the statistic is where we have that square root of P, 1 minus P over N. And that is the standardized test statistic. You don't have to write it in words. You don't have to write it in a formula. It's just, you need to know that because it's very possible they'll do that on multiple choice. They'll set it up like which of the following will find the test statistic. They won't say what is the test statistic, which will find it. So that's why you need to understand that formula. And it's nothing we've done before. I mean, we've done that. Statistic minus parameter over the standard deviation. I mean, that's what found the z-score in chapter 2. That's what did it in chapter 7. We've done that quite a few times in class. Okay, pencils. What questions you got? I want to show it to you on the formula sheet. I want to show it to you, just make sure you guys know it's there, because it is on the formula sheet, right? It is on the formula sheet. Let's go ahead and do that. Click. Whoop, made it probably too big. It's right above confidence interval. Standardized test statistic. Statistic, parameter, standard error of the statistic. Standard error of the statistic. I think I said standard deviation of the statistic, which is the same thing as there's not really any whatever. And then when you go to the next page, this becomes a little confusing because here's the standard error of the sample statistic, but we're not using that one. We're going back to this one because you know what P is. So that becomes a little confusing for you guys. And so that's why I tell you, if you know what the population is, use it. And you know what it is because that's what we say in the whole. P equals, mu equals. Everybody okay? Tomorrow or Tuesday, we'll go down to the 2-sample. Beautiful. And then you find the p-value with your calculator or Desmos or the table or whatever you want to do to turn that test statistic into the probability or the p-value. Same thing, p-value, probability. It's the probability of getting that, or more extreme, assuming HO is true. Click. Here's a normal distribution. Here's the 0.8. Here's the 0.64. Here's a normal distribution. There's 0. Whoops. Went away. Here's the 0, and here's the negative 2.83. This is the exact same one as the 0.64. This is the free throw shooting. This is the standard normal, right? They're the exact same. They're interchangeable. Yo. You could see one of three things, right? P hat is less than 0.64, or you might see Z is less than negative 2.83. Again, you need to put those together. Understand that those are the same probabilities from negative 99999 to 0.64, or from negative 99999 to negative 2.83. If it's to negative 2.83, the mean is 0 and the standard deviation is 1. If it's to 0.64, the mean is 0.8 and the standard deviation was that 0.053 or whatever that was. So we have the standardized test statistic, which is just simply the z-score. Once you have the z-score, you can turn the z-score into that p-value, because the p-value is nothing more than the probability. And then once you have those two things, you can compare it to alpha. And once you compare it to alpha, you can decide on what? Reject or fail to reject the null. And if you reject it, you have enough evidence for ha. And if you fail to reject it, you don't have enough evidence for ha. What was this one? 0.0002. I'm probably going to have to what? Reject the null in favor of the alternative. And I'll go back really quickly just to make sure. Where'd it go? There it is. Reject the null. I have enough evidence to say it's less than 0.8. Therefore, this player claims to be an 80% free throw shooter. I think they're lying. I've got statistical evidence that they are lying. I had some evidence at the start, 0.64. Now we have statistical evidence because 0.64 is 2.83 standard deviations away. Yay? Good? Okay. Anything? We're not done, but that's pretty much the whole, that's the gist of it. We'll break it down just a little bit further, but that's the gist of it. Clicky, click, 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 click. Click, click, click. Remember how to interpret it. We already talked about it. So here we go. We're going to get the E, right? We all want E's. We don't want P's. We don't want I's. I's are real bad because they're 0. Method. 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 We have two methods already. 1samp prop z int. 2samp prop z int. Now we're going to go 1samp prop z test. I know there's no telling where this is on your notes, but it's somewhere on there. I changed them up. I changed them up. I changed them up. Yeah, it may not be. I changed them up. 15 freaking years of the same course, and I don't ever do it the same way twice. You get better or you get worse every year. You don't ever stay the same. Trying to get better. Tell me the parameter and tell me the hypotheses. Tell me the hypotheses. You're going to, again, I try to get this down to rules of 3, right? So these are 3 things you have to have, right? You have to have the method by what? Name or formula. Name or formula. My first, however many years it was, I darn near required them the formula. But I have learned, especially after going to grade this past summer, that if a student puts the formula in wrong, you get dinged. And so I think, just from, again, what I'm feeling, you have a better chance of putting this correctly than the formula correctly. A lot of you guys can put the formula correctly, and I have no issues with it. AP doesn't care. You got to have a name or you have to have the formula. But if you put the wrong formula in there, you're going to get dinged. What if I put the name and the formula? The formula better be right. If you put something wrong, you're going to get dinged. Okay? So if you want to put z equals, where am I at? No. Cancel. Gosh darn it. If you want to put z equals p hat minus p square root p1 minus p n, you can. No problems. But as soon as you put a hat where you're not supposed to, you're getting dinged. I mean, I don't know that you will. Because like I said, you guys are doing a great job this year. That's P because you know it, so I'm going to use that P because I know it. Those aren't going to be hats. But if you throw a hat in there, they're going to ding you. Or you can say 1 sample proportion Z interval. If you leave out the Z, they're going to ding you. You got to have a Z in there somewhere. You got to talk about proportions somewhere. You have to tell me the hypotheses. You have to have a ho and a ha. And then you have to tell me what the parameter is in the context. This is context. Okay, that's basically context. We talked about that yesterday with the ho and the ha, and then tell me where P is the true percentage of free throws made by this Bentonville Tiger. Y'all okay with those three things, right? Ho, ha, define P, give me a method. Give me the method. All this doesn't have to be in the method. You just got to have it. You just got to have it. MC cubed. Conditions, calculations, conclusion. So we're going to go to the conditions. And guess what the conditions are? Random, 10%, large counts. Those are the same exact conditions. The only difference, that is now P, not P hat. That is the only difference. Still have to have an SRS. We still have to have large counts, and we still have to be less than 10% of the population unless it's an experiment. Unless it's an experiment. And very rarely do you see experiments on one sample. Most of your experiments come from two samples. I'm not saying you don't, but it's rare. Three conditions. Three in the method. Good enough for that, okay? Same ones. Woohoo! Guess what? It's going to be the same ones Tuesday. And it's going to be the same ones in chapter 9. This is chapter 9, sorry, chapter 10. And it's going to be the same ones in chapter 11. There are going to be the same conditions every time. How you prove them are a little different. Okay? Click. Calculations. I don't care what you put for the calculations. I mean, I don't. You have to have certain things. And so I'm trying to use this as 3. Somewhere you got to tell me what the variables are. You got to tell me what P hat is. Now, you already told me what P was because you did that with the ho. But you got to tell me what P hat is somewhere. You got to. You have to tell me what N is somewhere. You have to tell me what N is somewhere. Some of you guys do that in the conditions. So somewhere we got to have P hat. Somewhere we have to have N. Somewhere we got to have that Z significant value. And no doubt we got to have the P value. Like if I don't have anything, I got to have that. Because if I don't have that, that's an I. That's like a 0. You can give me a P value and still get some points. You don't give me a P value, you're not getting any points. Because that's what we got to have, right? We got to have that. We'd love for you to have an alpha value somewhere. Some people put the P value and the alpha value in the conclusion. Since P value is 0.002 is less than alpha 0.05, that's fine. We just got to have it in there. Kind of find you a little rhythm that you're going to do this stuff in. This is the one I think that really, really helps by doing this. Put the method, put the ho and the ha, and define P in one of those boxes. Put the conditions in one of those boxes. And then put everything you know that you could possibly do mathematically or calculations in another box, and then put the conclusion in another box. And if you do all that stuff, chances are really good you're going to not miss something. You'll kind of follow what I'm saying on that. I used to just be do this, do this, do this, do this. And I think students got so concerned with doing this and doing this and doing this that they didn't really know what they were doing. So I'm flipping and flopping this. I'm putting a lot of this on you guys to make sure you just do it. But how you do it is kind of how your mind works. What's best for you. You got to find that z-score. You got to give me the p-value. You got to give me the alpha value. You got to do something. This is where I used to make the students write this. I made them do this. If they didn't do this, I dinged them. I don't know why I need to do that anymore because it plainly says in the rubric by name or formula. But then right underneath that, I would have the students put what p hat was, 0.64 minus 0.8. And then I would do 0.8, and I would put 0.2, and I would put 50. And then I would say what this is equal to, which was, what was it, negative 2.83, right? You're kind of okay. This defined all the variables. It defined them all by doing it that way. But you don't have to do it this way. You can just say, hey, p hat equals 0.64. If you want to say p is equal to 0.8, you can, but you did that in the whole, so you don't have to do it again. N, we haven't said anything about N, but you may have done it under the conditions. So you don't have to state it again. But if you didn't, somewhere we got to tell me what N is. Somewhere you got to tell me what N is. I think it was 50 in this particular one, right? And no matter what, you got to tell me what Z is. Now, you don't have to show mathematically how you got Z because everybody knows you used your calculator to find that Z value. So just give it to me. Give me the Z value. I'll show you the calculator is going to do it all for you. Just like the confidence interval. All I needed was the interval. I had to have some other stuff with it, but I needed the interval. This, I got to have the Z, and we got to have the P value. We got to have those things. And then we'd love for you to talk about alpha. I just think it's good if you're going to say that P is less than alpha, I would love for you to tell me what alpha is. Most of the time the book tells you or the problem tells you, but I still like to state it. Am I going to get wrong? Dinged if I don't. I don't know what the rubric says. You're probably okay if you don't, but if you put it, you are okay for sure. Yay? Good? I don't know what all you want on this, what you want to show on this, but some type of calculations. Definitions. I don't know if I just had to have a C for MC cubed. And then our conclusion. And that's where we're going to write what we talked about yesterday. We are, oh no, that's confidence intervals. Since P is less than alpha, we reject the whole. There is enough evidence to suggest this cat can't shoot 80%. Since P is greater than alpha, I fail to reject the whole. This guy can shoot. Ooh, I don't want to say he can. I don't have enough evidence to say he can't shoot less than 80. Make a decision, make a conclusion, and then make sure it's in the context. Okay? Those rules of 3 should help you. I'm not saying you have to have 3, but by just keeping those in your head and by making a nice little table, it just seems to do a pretty good job of, man, I'm not too sure exactly what I need in there. But you probably could have done it somewhere else. You might have done, like you may have 4 things in something else, or what do you guys think? Yeah, no? This is like a 15-point question on your test. This is going to be on your test. It's going to say, is there statistical evidence? Actually, it might say, is there convincing evidence? Is there convincing evidence? And every year I'll get somebody say, yes. And they get minus 15. Yes, because P hat is less than P. I'll give you a point. That's not statistical evidence. That's evidence. There's a difference. Okay, questions? I did this one first hour. We'll go ahead and do the same. According to the U.S. Census Bureau, the proportion, you will know without a doubt if it's proportions or means. Okay? The problem's going to, you won't have to guess. Man, I'm not too sure if this is categorical or numerical data. We've done, you guys, if you don't know that, we're in big doo-doo, right? Students at high school who have a part-time job is 0.25. So we think 1/4 of the students have a part-time job. An administrator at a local high school suspects that that proportion who have a part-time job is less than the national figure. You guys can already see kind of how this is going. I got a ho, now I got a ha. She would like to carry out a test at the 0.05 significance level. The administrator selects a random sample of 200 students and finds that 39 of them have a part-time job. Explain why the sample gives some evidence. Good enough of that? That's my sample. That's p hat, which is less than p of 0.25. Y'all good enough with all that stuff? Guys, you cannot prove, it's impossible to prove that it's less than if my p hat's more than. If my p hat was greater than 0.25, there is no way for me to prove it's less than 0.25. My sample better be less than if I'm going to show that it's going to be less than. Okay? So that should help you as you're going through these problems. If your sample is nowhere close to what your high is, you can't prove it. If your sample is your ho, you sure can't prove it. These are like common sense type things that, again, I just wish you sometimes just use our head rather than just doing it. Everybody okay with that? Good? So now that I have some evidence, I want to see if I have statistical evidence. I want to see if I have statistical evidence. So I'm going to go through the whole full-blown process. Okay? This problem went a different way than that, but I'm just going to do the full-blown process. So, again, how you want to start, I don't care. Ho. P equals 0.25. Ha. P less than 0.25. Be careful. I have seen ho equals ha equals. Right? I mentioned that yesterday. Ho doesn't equal anything. And then I got to say P is the true proportion of students at this school who have a, was it part-time job or whatever. I need to do method somewhere. If you want to do it here, do it here. I like to kind of, truthfully be told, I do the method in my calculations. I do it in my calculations. I've seen teachers say, conditions have been met. We'll do a 1-sample proportion Z test. Good enough. I mean, that's kind of telling them, hey, I checked them, they're good. I don't think all that's necessary, but that's just beautiful English. Check. Oh, I didn't do conditions. I can't even say that. I got to get conditions. Okay. So somewhere on here, we got to do a 1-sample prop Z test. Can I leave out samp? If you got a 1, you're probably okay. Can I leave out prop? Yeah. Can I leave out Z? Right? Kind of getting iffy on some of this stuff. Don't leave out stuff. Just, I'm letting you abbreviate everything. We have a SRS. 200 students. We don't have to write a novel on this, but we just got to make sure it's not SRS check. Don't do that. Go a little bit further than that. I'm going to assume that 200 is less than 10% of all students. I don't know that, but it does say it's a large high school. We're going to go with that. I don't know that it's not. And then I got to do 200 n times p, which is 0.25. Don't use my sample. That's 50. And 200 times 0.75 is 450, which is greater than or equal to 10. Is it 150? No, should be 50, shouldn't it? Divided by 4? Oh, I'm not. Sorry, now I see why you said 150. Shut up. You guys have calculators, I don't. Look at there. I didn't have to erase the whole thing. I just had to erase the little. Okay, thank you guys. Appreciate that. First mistake this year. I've done that story, haven't I, in here, right? I make one mistake a year. My year just started. I made a bunch last year. My year just started, like just now. I got one mistake this year. I made a couple yesterday, but this year I've only made one. I did make a mistake one time. I thought I was wrong. Turns out I was right. I would love to see, Sheebers. I would love to see the sampling distribution. So the samp dist is approx norm. Not required, and if you're worried about running out of time, I don't think I'd put it. But man, that right there, I'm just telling you, from grading tests this past summer, when students started putting this kind of stuff, woohoo! I didn't grade near as hard all the way down because that cat knew what they were doing. Uh-oh. Yes, sir?
Hey, quick question.
Hurry.
On the girls for VHS,
Yep.
a couple of them I can leave off. What about Matea Peterson?
Probably not. Yep.
Okay. Number 31, Alexis Johnson.
She's for sure gone.
Okay.
That's all you need? Okay.
Oh, wait, no, I need one more spot. Kinley
McLeod? Yeah, probably.
Okay.
Good enough? Later. Sorry. Good, happy joy? What was P hat? 39 out of 200.95. Thank you. We got to have that in there somewhere. I would like to say that N is equal to 200. I'll go ahead and say that P equals 0.25, but you don't have to because we did it over there. I haven't. Yeah, I did it right here. You can double stuff up. It's okay. I think that's all I really need. If you wanted to be really special and you knew that the formula was Z is equal to P hat minus P square root P 1 minus P over N, you're good. But if you're worried about getting that wrong, then don't put it. mean, I almost don't know how you can get it wrong because it's your statistic minus your parameter over the standard error of the statistic, and that's on all that's on your formula sheet. You just might put a hat there and don't put a hat there, but if you do, then don't. I wouldn't list it. Everybody okay so far? Good? Because I'm getting ready to go to my calculator and find everything else I want. I'm getting ready to go to my calculator and find everything else I want. Whoops. Cheated. Stat. Test. Desmos will do it too, right? Desmos will do it too. I don't want Z test, just like I didn't want Z interval. Okay? I don't want Z test because Z test asks you for mu sub 0, but then it asks you for sigma, and I don't know that. And it also puts data and test up. It just messes things up. That's not what I want. Don't do that. Go here to stat, go to tests, and find the one prop Z test. You don't have to go down as far because it does all the tests first, then it does the intervals. So one prop Z test, and that's your method. You can put that. I really like 1sample prop Z test, but that's okay. All right, enter. P sub 0, so that's basically my hoe. That's my hoe, that's that 0.25. Here's X, that's my 39 people that have the job out of the 200. Please remember what? That X cannot be a decimal. It cannot. If it is, it's going to give you an error. So round it, okay? And then I go down here and then they say prop, and this one says not equals to. No, this one says, this one says less than hoe. That's what I want. I want it less than hoe. The next one says greater than hoe. So basically this is my ha. And I can go down to calculate, and when I hit calculate, man, it gives me everything I want to get. Here's my Z-score. Now this is my p-value. Be careful. I wish it would say p-value. It doesn't. Desmos will. But I think you guys are okay with that saying p equals, because you know that p is actually equal to 0.25. Right? Be careful. It's where all this p-ing is going on, right? Like I talked about yesterday. So p value is 0.036. P hat's 0.195. There's n. That's going to help you do what? Oh, I need to put those things down. I want to make sure I put those down. What if I don't? Well, I don't know why you wouldn't. It's sitting right there. You might be okay if you don't, but it doesn't hurt. But I got to have this, and I got to have this. Got to have those two. That's like a no-brainer. So now I got to remember these numbers. Negative 1.79. If you want to put negative 1.8, you're okay. I would put negative 1.79. Because if you put negative 1.8, that's not the p-value for 1.8, right? You know, it's kind of touchy on that. A little bit makes a big difference. So I'd put 1.79. 6. 2. I mean, you don't put so much, right? So we're back to my little keep, apply, slideshow. Z equaled negative 1, was it 1? P value 0.036, alpha 0.05. Where'd you get that? I think they told me, right? Okay, they told me 0.05. And now I'm going to my conclusion. Since p-value less than alpha, and I don't have to say what it is because I did it over here. And if you didn't do it over here, you can do it over here. And if you want to do it over here and over here, okay. I reject hoe. better see rejecto. If you don't see rejecto, but now each one of these are its own E, P's, or I's. So basically 4 points, 4 points, 4 points, 4 points. Basically, I probably did 3 points on one of them. Give you about 15 points. That's a 15-point question. Whew. If I rejecto, there is. Remember, less reject is. Greater fail to reject is not. I said is not first thing this morning, and I just marked it out. There is enough evidence to suggest, and I forgot. We're talking about what? Students with jobs. The percentage of students. How about the true proportion? I want to make sure we're talking about that population. The true proportion of students at this school. I don't want to talk about all students. Why? Because my sample only came from one school. Okay? At this school, the true proportion of students at this school who work, I'll keep that short, is less than 0.25. Don't say it's equal to 0.1, what was that? 195. We didn't prove that. We just proved it was less than 0.25. Who has a question about something? It's a lot going on, right? I don't think it's that difficult, other than there's a lot going on. I mean, when I'm up here talking about it, and when you're talking about it with your friends, I think you guys get it. And I don't think any of this is really new. This was new yesterday, but you kind of understand it, I think. The chances of that happening is not very good. So if it's not very good, you got to think that that's a lie. And if that's a lie, then that must be true. I just got to put all that stuff down. Yay? Good? Question. Click. That was proving that I had some evidence. There's the conditions, random, 10%, large counts. There's the Z critical value. There's Z less than negative 0.80. They drew it over there. You can draw it if you want to. You don't have to, right? I think it's good to, but I don't think it's required. If that was the only thing they asked, I would probably draw it. Oops, what am I doing? I don't want to do that. Exit. I do want to show you this. I forgot, right? When you go to stat and you go to tests and you go to one prop Z test, do notice at the bottom they have calculate, but then they also have draw. And draw is kind of neat in the fact that they draw the curve and they color in the p-value. And they tell you down here that this is a one prop Z test, and there's the Z critical value, and there's the P. So it's kind of neat. They just don't give you the P hat. I don't know how much they need that. It shows me it's far enough away. It's close though, right? 0.03. That's not a whole lot of evidence, but it's enough with alpha being 0.05. Now, if alpha was 0.01, I can't reject it. Kind of see that, right? So that matters. Alpha matters on some of these questions. Sometimes it doesn't. Sometimes it doesn't. Going back, slideshow, apply, slideshow, clicky, click, click, click. What conclusion would you make? We already did that. Because the p-value is less than, we reject. We have convincing evidence. We've talked about all three conditions. Make sure you understand why they're important and why we do them, right? We want to draw conclusions. The randomness helps us draw conclusions. The large count shows us that we can find a probability from a z-score because of normal distributions. And the 10% conditions basically works that standard error formula. I do want you guys to understand one trick that they will try to get you. Here's another question. Is there convincing evidence? So this basically is an entire question again. I don't want to go through an entire question, but you guys have notes here that you can go back through if you need some more confidence through them. Okay. There's the randomness, there's the ho and the ha, defining P, there's the Z, there's the Z, there's the Z, there's the P, there's the alpha, and there's our conclusion. When a significance test leads to fail to reject, just be careful about this, right? The decision, be sure to interpret the results. We don't have convincing evidence for ha. Anything that sounds like you believe ho is true or might be true is going to ding you significantly. We cannot say ho is true. There is convincing evidence that the true proportion of blemished potatoes is 0.08. No, we just failed to reject it. There wasn't enough evidence to say that it was not 0.08. Don't abbreviate FTR. I talked about that. That won't work. This is what I want to tell you guys, okay? This is the one, this is the get you multiple choice question. This is the get you. Won't get you guys, I'm telling you, because you guys are pretty smart. Ho. P equals who cares? Who cares? Ha. P does not equal the same who cares. Everybody okay, right? So we know what? This is a two-sided test. So what they're going to do, guys, is they're going to do all the work for you. They're going to check the conditions. They're going to tell you everything's good. And then they're going to give you a Z critical value. They're going to give you a Z critical value. Let's go ahead and say 2.01. And then they're going to say, at what level can you reject it or fail to reject it? Or they're going to say, what is the p-value? So basically, I got to know what the p-value is. Everybody okay? Good? So, knowing what you know about normal distributions, and you have a z-score, I hope that every one of you would either go to your calculator or go to Desmos and do a normal CDF from 2.01 to 9999999. Good enough for that? But you have to do something else after that, because that's not the answer, right? Because this is a two-tailed test, and if you go from 2.01 to 9999, I've only done one tail. Fair enough? So when you see that, you have to double it to get both tails. So you basically, guys, you have three choices. Three choices. You can go 2.01 to 99999 and double it. Or you can go from negative 99999 to negative 2.01 and double it. Or you can go from negative 2.01 to positive 2.01 and subtract it from 1 to get you what's left over. Good enough with all that stuff? That's the get you. That's the one like, man, I get this stuff. And then you get this one wrong. You still get it. You just got to get it. You got to know it. You can't just, my calculator does it all. No, it doesn't. It won't help you with this question. Okay? Now, I do want you to understand this, and this got me 2 years ago after emphasizing this so much. On this calculator, guys, if I do stat and I do test and I go down, get over here and do the test, and I go down here to one prop Z test and I do the not equals to, That will double it for me. That will double it for me. So you don't have to double it if you're doing all in here. Prove it. Whoops, sorry. Boom. I'll even draw it. It might be better to prove it. Boom, boom, and I got 0.07. So the calculator will double it for you. The time that you need to double it is when you're just calculating the p-value from the z critical value. Because if it's a two-tailed test, guys, what? Z-score could be on this side, or it could be on this side. It could be on either side. You don't have enough evidence. I mean, it's easier to prove that. It's easier to prove it because the p-value, but it's going to be, let me rephrase that. It's easier to show that it's different, but it's harder to find significant evidence because the p-value is bigger. And if the p-value is bigger, it's harder to reject. It's harder to reject. So it's harder to reject a two-tailed test than a one-tailed test because the p-value is always bigger for a two-tailed because it's doubled. Again, hopefully there's some aha moments. Hopefully through the homework, you'll start seeing some aha moments. Click, click. Two-tailed test, the alternative. This is what all this slides to. Here's a two-tailed test here. So this goes through the entire process. You can see how much confidence I have in you guys because I'm not doing every one of these examples. I'm not. I think you guys got it. I feel confident in you guys. I don't want to bore you by doing every example. But you got them there if you need them. Random, large counts, 10%, ho, ha, define P. There's the z-score. There's the probability. Notice that they'll write it differently, all kinds of different ways. There's the p-value, 0.03. Alpha's 0.05. Since my p-value is less than alpha, I'm going to reject it. There is enough evidence to suggest, and I don't even know what that question dealt with. Good? When making a conclusion, be sure you're describing a parameter and not the statistic. Be careful about that, right? It's wrong to say we have convincing evidence that the proportion of students at the school who said they have never smoked. That's inferring the sample. Be careful about that. I don't want to talk about the proportion who said. I want to talk about the true proportion of all students. Okay, so just be careful about that. I do want to mention this. There is a link between confidence intervals and a two-tailed test, right? Again, hopefully it just kind of makes sense to you guys. But if I do a confidence intervals, you kind of already did this already, but that's a confidence interval. If my ho is in the confidence interval, you have to fail to reject it. You have to fail to reject it. If my ho is outside of it, then you can reject it. Okay? But here's what I do want you to understand, because another type question, if this is a 95% confidence interval, that must mean that alpha is 0.05 because it's what's left over. Okay? If it's a 99% confidence interval, now alpha is 0.01. So alpha is whatever's left over from the interval. I do not think you can do a one-tailed test with a confidence interval. I do think you can do it with a two-tailed test. However, you still have to have a ho and a ha. You still have to ho and a ha. So if you feel really good about confidence intervals and you have a two-tailed test, you can do a confidence interval instead. You still just have to have a ho and a ha. Okay, that's what all that says. Remember, we talked about this lengthened words. Greater, fail to reject, not. Greater, fail to reject, not. Less, reject, is. I hope you can I hope you could have done that before today. Calculate the standardized test statistic. You could have done that before today, but now hopefully this just gave you the ahas. And the p-value, you could have done that before today. Perform a significance test about a population proportion. I'm not sure you could have done that before today, but now I hope you can. And then it says interpret the power of a test, and we're not talking about power yet because that deals with errors. And I'm not doing errors yet. I think you guys are pretty lucky in the fact of you guys got a little bit extra time to do your stuff, especially seeing how it's not looking good Monday and Tuesday. Who knows what, right? Who knows? We got a couple of wiggle days in here in this semester. But like I told you yesterday, I got to get done with this course by a certain date. And I want to get done spring break. Because I want you guys to go on spring break and not think crap about anything. And when we come back, we're going to hit it hard for that month. Good? But we're only going to hit it hard in class. We're not going to hit it hard at home. We're going to hit it hard in class. Because that's why I work you guys hard enough all during the year. And we're just going to focus on that test. So hopefully we get a little bit of snow and we get to go out and enjoy it. But it's going to be so miserable cold. I need to hit stop recording because nobody else wants to hear this.